So thank you. Good afternoon, everyone. Thank you for the introduction, Claire. And I'm really pleased to, on behalf of dCache developer team, to use this opportunity and to tell about how we maintain our software for HEP community. So over 2 decades, dCache project was delivering an open source software to satisfy demands in the storage requirements. So more than 100 sites around the world rely on dCache to provide storage resources to WCG communities, to Belle-II, European EuXFEL, the Rubin Observatory, LOFA Observatory, and many others. So today, agenda is, I will start with the motivation of dCache. So why we did create a dCache in the first place, its role in a scientific data management, our development process. I will describe our pipeline implementation and our community engagement. And finally, I will show how we keep dCache up to date. So I hope by the end of this seminar, you will have some idea what takes to run a software project like dCache for more than 25 years. So small disclaimer here, you shouldn't take whatever I say as a 100% true. So if you have things that works for you, keep them. And if you just start from zero, then you might learn something and use it as a starting point. So let's start why we need the dCache in the first place. So the motivation behind dCaches was pretty simple. So data never fits into a single server. And as scientific experiments grew, so did the need for data management. So data start to spread on the multiple servers. So some data should go on a tape, some data was only available on tape, it shouldn't be recalled on demand. And the sites have their requirements, what they can run as a hardware on the software to make efficient use of people that they have available to running the systems. So as a result, back in 2000, the joint effort between DESY and Fermilab and later on NDGF, we start to build a system that is today known as a dCache. So the goal of dCache was to combine multiple community data servers into single-rooted virtual file system, and systems should scale with a number of machines in a system. So by adding new machine, both the bandwidth and overall capacity of a system should grow. So every site that runs dCache that develops dCache runs dCache as well. So historically, every site has its own internal focus. So DESY mainly is focusing on the core components and the local data access, like accessing through dCAP or NFS or XRD. Fermilab was engaged in providing grid FTP and SRM and space reservation. So now they're working on their replacements like XRD third-party copy, bulk service, test REST API, quality of service. And the GF, by their distributed nature, was mostly working on getting system operational in a distributed environment and with the focus as well on the maintenance. So by the way, this image is the original proposal draft from 16th of September 2000. So last week we turned 25 years. And some people you still can see around. So Martin is definitely connected here. Patrick Furman still works at DESY. Rainer Mankel still works on DESY, and Michael Ernst was working at DESY and Fermilab for many years. Good. So what are the key goals that dCache was trying to address? So one is the location transparency. So the user shouldn't know which file lives on which data server, so that we take care about it. So the location independence. So file name doesn't change if we move a file from one data server to another data server. And in many cases, we provide as well network transparency that remote files are accessed like local files. In addition, we provide the user mobility, so users can access the same data same way from different machines, so they don't need to change the way how they're accessing if they sit on different machine. One of the key aspects of dCache functionality is multi-protocol support and multi-authentication support. And the way how we do this is if data is written over one protocol, let's say through HTTP, using the grid certificates, and then later on accessed locally via NFS, then we can use simple Unix permissions, or they can be XRD with the tokens. So internally, we always map independent from how user comes to the system to same internal identity and providing a user the same capabilities that he wants to have. So such multi-facet behavior of dCache makes it essential part in multi-cluster infrastructure. So here on this picture, you can see so-called interdisciplinary analysis facility, or IDAF, the system which is deployed by DAISY, or the architecture that we have at DAISY, where we have HPC cluster, grid cluster, and local batch cluster serving different scientific communities. And as you can see on the image, they all accessing dCache as well. So these all methods that they access and the behavior of these different communities must be reflected on our testing process. So over the last 25 years, so dCache grew significantly. So we did in this 25 years more than 1,700 releases. We have 142 branches. We have weekly releases that we do. We have 2 branches that called so-called long-term or golden releases that we maintain in a parallel, so they get the updates for 2 years, which was in the past bound to LHC shutdowns and running periods. And we have more than 160 contributors from different institutions. So our branching model is based on using master branch, and all development happens around the master branch. So time to time, every 3 months, we cut off the master branch a release branch. And the way we distribute the fixes later on is the fixes always go to the master branch, and from there they get backported to all supported branches. So we backport only bug fixes. We don't backport functionality. There are always some exceptions. For example, switch to SHA-1 certificates or switch to Globus 2 forced us to do this kind of breaking our rules. But the idea is that if sites do minor updates, they don't observe any new behavioral regression. So that's why we try to backport only things which are really bug fixes. From software layout perspective, we're using concept which called convention over configuration. So this means that the projects looks same independent which type of project it is. So if you have, so in our case, it's a Java project, so we use standard Java project layout, which makes it easy. Any Java developers that we can get, student or experienced developer, knows right away where our source code is, where our tests are, how tests started, where the dependencies and configuration files. So this makes onboarding pretty easy. And obviously adopting of tools makes pretty easy as well. So downside is if you do something which is non-standard, it's really hard to get in. And as a dCache written in Java, for example, producing RPM or Debian packages is pretty challenging. So onboarding is very important part of developer process in general. So to make it simpler, what we do, we keep set of tasks on our GitHub issue page, which are marked as easy pick or educational tasks, which newcomers can do. Usually these tasks require very little knowledge prior, starting to work on it. It's very compact. So either it's language specific or single file specific. So you don't need to know all rest of the dCache to do this. And maybe it makes sense to mention that the dCache is about 500,000 lines of Java code. So the way how we collect this tasks is based on the matrix that we use for triaging issues. So when new feature requests comes, or when we just by expecting code finding some part which have to be changed, we try to put it in one of the four categories. So there's a one category which is easy to do, high impact. The other is easy to do, low impact or low priority. Some of them are difficult to do by high impact, and finally there is one category which is difficult to do and it's low impact. So the last category is pretty easy. We just don't do it. We just drop it. So the first category, easy to do, high impact. This is things which we do right away. So difficult to do, high impact. This is our long-term planning. And things are which easy to do, low impact or low priority. Those are collected in these easy tasks and educational tasks that we can keep on the side, and we don't need to fix them because they have low impact, but we keep them for newcomers to work on this. So one thing to mention is dCache project is not the same as a dCache operation. So developers are not the people who run the software, even on the sites. Well, we might help our local admins to do it, but in general, our admins of people from Fermilab, NVGF, and DAISY, they download the same RPM packages from our web page as anybody else. So the software that we provide as a project is not always the same that the sites runs, in a sense that sites might be behind of what we do, or other sites might be ahead of us. I think dCache 9.2, the BNL was the first site who installed it in a large scale before, for example, DAISY or Fermilab was running this. So this makes it's really challenging for us to ensure that the software runs as required. And as a dCache is a persistency layer, you cannot tell the people just wipe everything and start from scratch. So cover this, we have so-called process and this ground release process. And this release process gives us a stable and consistent way to have a reproducible and predictable builds every time. And so this is the pie chart of changes that we did in the last 18 months in sense of number of commits. And you can see that the majority, sort of half of it, is just goes into CI. Is not improving functionality or adding new features, is just getting CI done. Right. Maybe some people will be surprised if you look in the graph, you will see that documentation is the fourth things that we do, and people are still complaining that we have not enough documentation. Good. So let's have a look on some parts of this process, and I will just go in some details how the tagging in GitLab, in GitHub, will brings the packages on our web page. So for this, we need to first understand a little bit of how dCache works internally, just to give the sense, the complexity of testing there. So as mentioned earlier, so dCache is a distributed storage system that consists out of many data servers exposed as a single file system. So dCache has entry points, so-called doors. So the doors talking one of the protocols that user using to access data. So it can be HTTP, XRD, or NFS door. So the data servers are talking all protocols, and on a request, users are redirected to appropriate data servers. We use internally Postgres database for metadata catalog, and all auto discovery of a system happens using Apache Zookeeper. So this is a coordination service which was developed for Apache Hadoop. So obviously, users using different authorization mechanisms when talking to the system. So all these interactions we have to test, and we test this on each commit. So our code base lives on GitHub. This is deliberately our choice to make it more visible to others, but our build infrastructure is at DAISY. So we use DAISY GitLab system or as our CI. So which means on each commit, we mirror whatever goes in GitHub to our GitLab server at DAISY. So in our IT infrastructure, or in our CI infrastructure at DAISY is based on Kubernetes. So we use two Kubernetes clusters. So one is using shared runners. On these shared runners, we use tasks that are have low impact on other projects. So for example, we just compile code there, or we upload our build artifacts, or do something which is not that heavy in a computational or load point of view. For heavy duty workloads, we have our dedicated cluster, which is still provided by system group at DAISY IT. Nonetheless, we have zero dependencies on any other DAISY infrastructure. So technically, our pipeline can run anywhere where GitLab exists, and there are runners which allow to spawn new containers in a containers in Kubernetes. So our test pipelines has several stages. All stages together trigger around 35 jobs. The stage covers various aspects of our build process. So the first, we build the cache packages, these RPMs or tar files, which are later on will be deployed. For our test environment, we prepare the Kubernetes namespace, and we create a Kubernetes namespace per build. This allows us to run multiple builds in parallel. This is important when we do releases, and usually we do releases if we have some bug fix and affects multiple branches, then we will have a 5-6 branches built in parallel, which we need at this time. So 35 times 5, whatever number it is, so many containers to run. And they shouldn't interact with each other. So we create a namespace per each of them. So we have a lot of third-party dependencies. So it's a Postgres, Zookeeper I mentioned already. So they have to run there as well. Then we will deploy dCache, run the test, collect the log files. And if it's a release build, then we will put the RPMs on our web page. So technically, if this is a release build, just pushing the tag, software tag, will trigger the full pipeline, and after 1 hour, packages will be available on the web page. So we don't have kind of a zero interaction there. For our test infrastructure, we have to mimic small site. So we need to do everything which a small site have to provide. So in addition to Postgres, Zookeeper, we run as well Kicklog, because we have to generate tokens for testing. We run our CA because we need to generate certificates for testing. We run the worker nodes because we need to run user-specific workload. And this everything is part of our CI pipeline. So we don't run them separately. They are spawned as a part of our CI. For deployment, as dCache sites cannot always update dCache in one go, we need to provide a way how these rolling updates are happening. This is especially difficult for distributed site like NDGF, where they have multiple universities and the coordinating update for them is not a trivial task. So sometimes they run data servers of different versions. So to ensure that all data servers are compatible between each other, we run now in a pipeline 2 versions of dCaches at the same time. So this change we have added pretty recently, because in a 9.2 series last year or year before, I don't remember anymore, we broke the compatibility, which was not good. So now our testing environment runs mixed version. So as you can see, our test pipeline is not the static, but we update it as it needed. To deploy dCache in Kubernetes, we're using Helm chart. So the Helm chart comes with pre-configured dCache setup, which as well mimics very small site with everything which is needed. So at the end, at the moment, the Helm chart is designed for testing purposes only. However, we might polish it to make it production ready, that there might be some deployments, sites that might have a deployments based on Helm with Kubernetes. However, as we are not the Kubernetes or Helm experts, so here we rely on the community to help us. Unfortunately, not all. No. Okay. So on testing side, we test as much as we can. So some test comes from early days. For example, this S2 SRM compatibility test was developed in something around 2006, 2007, and was used during the SRM deployment. Other tests are added as needed when we start to work with the tokens. For example, XRD with tokens have been added recently. And other tests are just coming from other communities, like NFS protocol compatibility tests is something which is written by University of Michigan and now maintained by Oracle. So all in total, we have about 6,000 different tests that we run. Unfortunately, not all tests are automated yet. So there are some test cases that we test manually. For example, NFS kernel client compatibility is tested manually because we have to manually build a kernel, upstream kernel, and check that it's still compatible with what we have. Performance testing is done manually because it requires real hardware. We cannot use Kubernetes. We never know what else is running on this machine. So this performance test is done manually as well. Database schema migration, availability, failover. So there are some scenarios that we still do manually. It's very time consuming and very frustrating. So we still have a lot of work ahead of us to automate this as well. So in summary, this full pipeline looks like this. So you see left to right, there's a multiple stages. So stages run sequentially, and within stage, all jobs run in parallel. And different parts of stages have different goals, right? For example, build stage just makes sure that we can build the software. So technically it says, is dCache broken for developers? So that the deploy stage checks whatever the packages that we build in a build stage are deployable, and we can start dCache there. Or in other words, we check, did we broke dCache for our admins? And the testing stage is finally checks the functionality. So did we broke dCache for our users? And this kind of scheme allows us to find early enough if there are some problems with the software. One of the big dependencies that dCache has is a Java virtual machine. So over the years, we adopted multiple multiple Java versions with the changing functionality. And this gives us, but we As this is a routine operation, we come to the scheme that allows us to benefit from functionality that comes with each release. However, we cannot run every dCache, every Java version that we want as a developers, because we stick to JVM that delivered with our target OS. And for now, our target OS is Red Hat 9. With switch to containers, this might be improved, but there are very little, not very little, there's one site that we know runs dCache in the containers. This is the Lugano Supercomputer Center that runs dCache in the containers. All others run on physical or virtual machines. So this Java migration is never-ending story. However, we have some time-proven strategy how we can do this. So first, we make sure that we can run dCache with a newer version of Java without doing any change code. So here we rely on backward compatibility that Java guarantees. This was kind of the promise made by Sun, and we are lucky that the Oracle still keeps this promise. So at this stage, we can identify some incompatibilities which comes from JVM. For example, some restricted ciphers, some security policy change, IPv6 enabled or disabled by default. So this is at early stage we can identify it. For example, today we use Java 21 during our tests, but we do our builds with Java 17. So later on, we switch to new compiler version, we update our libraries and our dependencies and use new language functionality. And this works very nice for us. The last thing that I want to touch before I conclude is the way how we communicate to our users. We have several channels that we can access our users. This is a mix of issue tracking system and mailing lists. So our issue tracking system that we run at DAISY are backed by mails. So if you send an email, it will end up in our issue tracking system. So we have the one which is usually used by our admins is support.dcache.org. So here admins can ask for help. They can share their configuration files. They can share their log files. This is something which closed, not publicly available information, only the people who opening the tickets can see, and as well all developers. We have another list which called security.dcache.org, which is for security sensitive information. And as this is sensitive information, not all dCache developers even have access to it. So only a couple of only a couple of developers can see what's going on there. And if we have ticket open there, usually we then ask EGI security to perform some severity assessment and help us in designing the way how we will release the fixes. So for just software bugs, we use GitHub issue. This is a public place where everyone can ask for either report the problem or ask for some enhancement or propose the fix. We have historically as well this SRM deployment list, which is used by tier 1 sites, where we weekly can talk to them to find out they have some precious issues. So the most valuable is our user forum. So our user forum is where site admins can help other site admins, and we have quite some experienced site admins that always help others. So I can mention Onur Sevs from Zara, Xavier Moll from KIT, or Christoph Anton Mitterer from LMO. So they really, really try hard to help others there. So in conclusion, I just can say that I hope you was you are convinced by now that having a project that lasts 25 years is not that simple, but it's not just a single site or single technology, but it's a joint effort between sites that developing it, community, long-term planning, and a well-established process. Over the last 25 years, we was able to develop a pipeline that ensures the quality and reliability. So our kind of ultimate goal that on a Friday night of December 24, people can just update the system and be sure that everything will work. I think our architecture is scalable enough and flexible enough that we can evolve the software without getting old. And we are really happy that our community is behind us. That's it. So thank you. I'm happy to answer your questions.
Great. Thanks. That was very good. That's some good tips in there too. Yeah, if anyone has questions, obviously they can raise their hands. So I'd like to go ahead with some. So I have, okay, I'll start with an overarching question, which is generally your experience since you've been on this project for 25 years. The contrast between working on dCache in the early days versus now. What is important now versus what was important back then? And generally, what lessons, maybe this is a hard question, but what lessons were important back then that are actually not important now because of the environment changed, the challenges changed, or lessons that are still remain important?
I think it's a very complicated question. So it started obviously, yeah. So dCache started obviously as a not being a product. So now we are kind of treat ourselves as a product. While when we started, we have been a service at DAISY. So people who was developing dCache at DAISY and then Fermilab, there's been people who run the system. So now we see our users through our mailing lists or through the conferences, right? So we are not right away if we break something. So in the past, common practice, we update the system, we see crap doesn't work, we patch and redeploy right away. So we don't have this luxury anymore, right? This is now should be rock solid from a first go, which not always works, unfortunately. This is number one. Number two is, as we have been people who are running the system, and we have been as well people who was collecting requirements. So we was deciding what should be added. Yeah, at the time when dCache started, this was for at that time High Lumi or High Lumi Hera or Hera upgrade, I think it was called at that time. So we knew our customers from H1 and SUS, we know their requirements, and we can deliver in advance. So now we get most of the requirements external. So we're getting without pointing to other experiments, but some experiments wants to have a token doing this, other experiments wants token doing that. And sometimes this is contradicting. Sometimes they want it today. Sometimes after you deliver, they don't want to have it anymore. And this is very hard to really find out what is really important, what is not really important. Because in the past, we could judge ourselves the priority list. So now it's harder to get the priority list. Very often we have to guess. We still have very good contact to our site admins locally here at DAISY, at Fermilab and the GF, so we can understand what the real experiments wants, what their real problems are. But this is much more complicated now. This is number two. And number three, what's changed is, I didn't mention at all, it's a scale. So when we start dCache, I think we run about 5-6 machines. This was big installation at that time. Now, so DAISY EuXFEL instance, for example, it's 400 machines. It's a single instance. And there we have completely different scaling problems. It's not only getting the RPM installed on the machines. This is done in a second because they all use Puppet now. Nobody installs RPM by hand. But collecting all log files, understanding where the performance bottlenecks are, to identify where the user misbehavior, system misbehavior, network misbehavior. So it's just get everything more complicated. So our goals next to getting the CI rock solid is as well to reduce the operational cost in the system. For high Lumi, if we expect 10 times more data, we shouldn't expect 10 times more people who run the system.
Okay, yeah. Yeah, I was also wondering on the scaling. And whether the system you developed early on was that ready to be scaled, or you basically had to just rewrite part?
We didn't have the big rewrites. So we follow evolutionary model. So what we try to do is we try to guess what our users will want in the future. We did this last 25 years, we did the replacements of our namespace server, for example. When we started with dCache in 2000, I think that 2001, this is when we start the first production use, when the first analysis jobs start to run. And at that time, accessing file, the opening file taking 2 seconds was okay, because the people was always comparing with the reading from tape. Now dCache very often used without tape system, just like a disk system. And we are fighting for now milliseconds to get the open times. Right? So we have to change the way how our internal messaging is encoded, how our namespace is structured, optimize the thread pooling that we had, make use of the hardware that is available, more CPUs, more cores, more network, more disks. But we always try to do this evolutionary and not having kind of big bang. So even for sites, it looks sometimes big bang because they update and then they get something new. As a developer's perspective, we did this over multiple years. It wasn't in a one day that happened. This is the one thing. The other thing I just forget.
Maybe I'll come back to you. Yeah, then what I was also wondering about is how long will developers typically develop on dCache? I mean, how often do you have to train new people, and how long do they stay typically? And how important? Yeah. And how
You
big
mean
is
for
your
developers?
Yes,
for developers. Okay.
Yeah.
Good. So the first, I remember the early question that I forget. So I wanted to say that we have too many sites running for different communities, including DAISY. So at DAISY, we have 8 different dCache instances, and the Fermilab has 2 different dCache instances where we have completely different user access profile. So at DAISY, we have this large EuXFEL, which is 400 machines, 120 petabyte on disk, with the files being there, should be there next 10 years. And we have dCache, which is behind Nextcloud, which lifetime is a couple of seconds because people write the document Control-S and it's overwritten. Or we have machine group, which writes telemetry from accelerator direct to dCache. So we have different use cases, and by these different use cases that we have at sites, we can anticipate what the other sites will have and which part of system should be improved before many sites will affect this. Now coming to this developer things, it's obviously a challenge. So there are some people who part of the core team being here for a while. So I'm the one who started at the beginning. So Dmitry from Fermilab, I think he started around 2005, 2004, he's as well about 20 years in the project. Some other project members are coming and going. In the past, we get the very good person fitting from EU project, which gives us possibilities to implement, for example, token-based authorization, WebDAV, microrunes, a lot of things which was done through EU projects. And there we have the way to get people in some part of the system. So they don't need to know everything. They need to know the general concept, so how the distributed part of it works. And then they can concentrate on a smaller part of it without knowing everything. So for some people, it takes half a year. For some people, it takes a week. I mean, it depends what you are doing. So unfortunately, due to the way how the people are funding in Germany and maybe everywhere as well, we cannot keep a lot of people for a long time. So usually after 3 years, some members in a team will be replaced by somebody else from a different project. And this is really a problem because, yeah, this is always overhead to get new people, right?
Yeah, exactly. Okay, and with your whole strategy with the labeling for issues as education or easy picking, I was expecting that you actually have quite a few developers that come and go.
Yes.
Yeah.
This actually started as a exercise with the University of Applied Science in Berlin, where we had the course on open source project, and we collected tasks for them. And at that point, we start to keep this is the way how we collect these tasks, that not only for students but as well for newcomers in the team, that they can have a starting point.
Yeah. Okay. Before I go on, is anyone else want to, add to that or ask the question? Eduardo?
Hi. Hi, yeah, thanks so much for the presentation. I thought it was very comprehensive and very clear. So I was just curious, and maybe you were going to say no, but in any case, just naively speaking, okay, if you look back, of course, things such as tools such as GitHub and Git, of course, have been transformative in the way we develop things, especially for big teams, right? And also in the way you can actually collaborate more effectively. Do you in your team see any say big wish of a tool, something that would be again transformative in the way you develop your project? Like do you, for example, you mentioned a lot about the CI, the fact that deploying is very sensitive in your specific case. So anything like a mock-up type of deployment, I don't know, something like that you would see as really making a big difference, a phase shift in the way you develop things. Is there anything that you have identified or not really for the next 25 years?
Okay, thanks for the question. You will be surprised, but GitHub have had probably zero influence on how it was developing. So from beginning, as we started the project with the Fermilab, we had always the code repository being our central place, how the code was exchanged between developers. So in these 25 years, we changed 4 version control systems. So we started with, well, I don't keep the tar files as a version control system. We started with CVS, then we switched to Subversion, then we switched to Mercurial, then we switched to Git. And at that point, well, some of them makes life easier from backporting. So the Mercurial and Git was just wonderful for backporting. Everything else was disaster to do backports and releases. But in general, it didn't change the way how we developed. So real change was CI, because when we started with the central Jenkins service as our build environment with the virtual machines as a workers, this was a real game changer, where we can run multiple dCache versions in parallel and have a multiple releases running in parallel. I think this is the key things for us, at least now. I wish it would be much simpler than it is now, because to get the CI how we have it now, we need to, as a developers, understand how Kubernetes is working, how Kubernetes is deployed, how Helm chart is written. There's a complexity to get this thing running. And if in the past it was sufficient just to if I compile code, I can run it. Now, if I compile code, it doesn't mean that they can start it. And this makes the, so if this will become simpler, I think it will help a lot.
Okay, yeah, I understand. Yeah, thanks. Yeah, so I was not appreciating that perspective. Okay, yeah, thank you.
Thanks.
Michelle?
We cannot hear you.
Thanks for this presentation, Tigran. Just to follow up on what you said, I'm a bit surprised that you said that GitHub has basically no influence on. I understand one of the things you are saying, but I have the feeling that it seems that you mentioned that there are the team developing dCache at Fermilab, at DESY, in NDGF, but there are maybe also contribution from others, or is it completely just you doing this? Because one of the features that I think helped with the project, where there are many contributors from different level and different part of the world, is that it makes the collaboration, the contribution of others much easier to integrate, to review, to. Is it something you are exposed to, or in your case you just have the core team doing development, so it's not so much an issue?
So the move to Git, so I mentioned that we was using Mercurial. So move to Git was
GitHub.
Yeah, so the move to Git was because we wanted to host on a GitHub.
Okay.
Yeah, so the idea was that if project is in public Git repository, so maybe we can engage more people contributing. So there are some site admins that added, so they updated the documentation. Yeah, they corrected the error messages that in a way that they better understand. But it's not that we have millions of contributors and the people just hammering and they want to contribute. It was very, very moderate. So what actually happened in dCache, we have our internal other components which are not very dCache specific. For example, our X3D implementation can run without dCache. Our NFS implementation can run without dCache. Our RPC implementation for Java can be run without dCache. And those are exposed as an external library on GitHub. So dCache uses them as external dependency itself. And there we see that some people make use of it and contribute. So there, yes, we benefit a bit. But in a core dCache that we say, okay, now all sites that run dCache wants to become dCache contributor, and the Git was the barrier is not the case.
But just to follow up, because one thing in my experience with, let's say, big projects, and you mentioned it, which is challenging, is to have, let's say, an up-to-date and comprehensive documentation. And my feeling, and my experience in some projects, is that the best improvement to the documentation have been reached when we were able to engage users, to not necessarily to write the core documentation, but to fix it, to improve it, because as developers, it's very difficult. First, you don't have the time, and you don't have all the experience. You are not doing all the crazy things that the users will do. And so having them, if not contributing to the code, but at least contributing to the documentation, is it something that you consider that helped dCache with this aspect of the project, or is it something that has been also quite negligible in your case?
So this happens indeed. So we have site admins that when they read the documentation, they says, okay, it's written bad, or the software change documentation is old, and sometimes they correct it as well. This is very nice, and this indeed happens. And maybe so HEP Software Foundation is the place that this kind of people can be recognized for their work. Right? This is so we do this during our workshop, but the community knows them, or the community already knows its heroes. So yes, so there we obviously, by making this entry very simple, yeah, we just click on a file in a GitHub and it says, okay, edit, and then the fork is created and then updated, and then so yeah, we have the cases where this happened, and I'm pretty sure if we didn't have it on GitHub, it wouldn't work that way. Yeah, even if we host it probably at DAISY, it won't happen that way. That's why we have this kind of neutral, well-known place. And this is the same way done, not only our code, but as well our release notes, dCache web pages, what else? I mean, all secondary things which we have there as well in GitHub, so that our admins have full access and they can contribute if they want. And this happens, but it's not, it's less than I wish. Let's phrase it this way.
Okay. Thanks.
So if you look who is contributing, you will see that it's 99% DAISY and Fermilab, and then the GF, and then maybe very little from other sites. And this is actually a big problem. So this is the thing which I would say, yeah, what went wrong, and went wrong, we was not able to get the sites that use dCache start to more contribute to it.
Thanks.
All these questions on GitHub also remind me of another question I had, was if you're using or starting to use AI tools for code review or for documentation.
So writing code comments, yes. I think our colleagues from Fermilab start to explore agentic AI for code development as well. But in our internal dCache discussions, so developer discussions, looks like that they spend more time convincing AI to do what they want than it will take them to write the code. But it's there. When writing documentation helps, doing things which we are not experts. So everyone who have seen dCache administrative pages knows that it doesn't look very modern. And if we need to fix something there because something breaks or security or whatever, well, we ask these new AI tools how to get this JavaScript thing to the way how our user wants, because we have no idea how to do it. But it comes. I mean, we want this or not, it comes. Our ideas just out of box. Well, they luckily recognize dCache as a valuable open source project, so all dCache developers even getting free Copilot from GitHub. And it's there, just start to suggest you something, but it's not always what you want to do. But probably in a couple of years, it will become smarter. So I'm not thinking that it will replace us soon, but soonish.
I know what you mean. Okay. So I just had a last question on the future of dCache. What's if you have anything on like what's next for dCache, the next big project or direction?
Right. So indeed, I didn't mention this. So we have, well, I mentioned as a part of the answer to the question. So indeed, we have main directions here is that we're looking at is scale out. So we know that Hilumi LHC, Petra 4, Dune, SKA, yeah, the other communities, they will have huge amount of data. The way how it's handled today definitely doesn't work. So we need the system to require less babysitting. We should assume that the part of a system always will be down and unavailable, so it should survive partially unavailable components better than now. We should improve monitoring. There's a lot of things that internally dCache can tell sites, because we knew in advance that we have too many requests, that the loads is too high, that the disks are slow, that the network is slow, but those informations are not exposed yet. So we started to work on built-in Prometheus exporters that we can hook, or sites can hook the monitoring system direct into dCache that will suck this information and then expose it. Then looking for user access anomalies. Currently, every morning starts that the site admins look at the plots in the graphs to see is there something went wrong over the night or over the weekend. This should be improved. So we have summer student project this summer who worked on the machine learning, try to get into anomaly detection in dCache. So we had these things now demonstrated that it works. We had already in the past with the summer student project for 2 years, did that we do Spark-based analysis for our billing information or our access log files. So now we will try to merge both of them to make some kind of automatic alarming and saying the system sees something which is not usual behavior, and then admins have start to look at it, and not every day, but only when there's a reason for this. These tools are available, so there's a lot of things done in big data communities in machine learning and Spark-based analysis, dust-based analysis. So this can be put together. So probably most of the effort in the next 5 years will go how to make the scale out in a system not be scale out in a number of people who operates this.
Yeah.
And the third thing, which is very strong, is HPC workload. So we see that the sites more and more looking to have, instead of classic grid clusters, having HPC clusters that do as well grid job. And there we might try to get as maximum as possible from this tighter integration, because up to now, the all storage systems that we use in for LHC, they have their own behavior, which is not HPC friendly or not HPC compliant, and this should be changed. So for us at DAISY, we already exposed dCache to our HPC cluster over NFS mount, but this is only the first step. We have to check that the scale out is correct, that our admins not always complain that the system doesn't behave the way how they expect, and as well integration with their batch system problem. So these 3 things that will dominate next 5 years.
Yeah. Okay, thanks. Thanks for the very complete answer. There. And I think that was also a good point to wrap up.
Good.
Thanks again for a very interesting presentation.
Thank you very much for the opportunity. And I hope someone can make use of whatever we did last 25 years, and then they didn't spend this hour just for wasting the time. Thank you.
No, I'm sure. Yeah. No, lots of words of wisdom. Thanks a lot. Cool.